All right, so now we're going to look at an example from start to finish of how we do a line of best fit. So the first thing I want to do is find my X bar and Y bar. I'm going to do that using 2var stats on my calculator. So the first thing I'm going to do is I'm going to go into my stats and I'm going to edit my list of data. So I know I have data in there already, so I'm going to clear it out. All right, so now I'm going to enter my sets of data. And my second list, 47. All right, so just want to do a quick check, make sure I've got my points. 55, 25, 40, 15, 45, and then 47, 28, 36, 42, 34, and 41. So now I can come back to my home screen and I'm going to calc 2var stats. These are two different variables, time and temperature. So 2var stats, list 1, list 2, calculate. Now this is going to tell me my X bar value and my Y bar value. So my average of X's is 30, my average of Y's is 38. So X bar is 30, Y bar is 38. So I'm going to plot my mean point. I'll leave that in blue. So 30 and then 2, 4, 6, we're counting by 2.5s. So 5, 7.5, 8. There's my mean point. I'm going to put my other points in using black. So 50, 47, 50, 47 will be just about here. 5, 28. So 5 will be halfway, and then 28. 25, 36. 35, so 36 will be about here. 40, 42. 15, 34. And then 45, 41. All right, so now if I'm going to determine my R value using technology, okay, let's do that. So stat, calc, linear regression, list 1, list 2, and I might as well store the equation. Okay, so I see that my R value is 0.973 to 3 significant figures. So a line of fit is appropriate because my R value is very high. So R is greater than 0.87. Therefore, a line is appropriate. So I'm going to draw that in. Remember, I'm going to go through my mean point. So if I'm drawing it by hand, I'm going to go through my mean point. Let's make sure that it comes out straight. What is going on? So clearly does not like my shift key to make straight lines like it should. So I'll do it as best I can. All right, I've got 2 points above, 2 points below. I'm pretty close to this point. So here's my line of best fit. Using my drawn line, predict the temperature. So using my drawn line, not the calculator line, the one that I drew, 35 minutes. So 35 looks to me that it's at 40 degrees. 75, well, my line would need to keep going. 75 is going to be way over here. So if my line kept going, I would imagine that would be somewhere around here. So maybe that's close to 56. So this one is reliable. So 3540 is interpolation, so therefore it's reliable. The 7556 is not reliable. It's so far outside of the data, it barely even fit on my graph. All right, use my technology to calculate the linear regression line. So we did that. Here is the equation for our line. So we have to transfer this into an equation. So this is going to be y equals 0.365625x plus 27.03125. So I'm not rounding here because these are exact numbers. They stopped. So that means they're exact. Use this to predict how long a car has been left in the sun if its temperature is 38 degrees. Well, temperature is my y-axis here. So this is degrees Celsius. This is minutes. So I want my y value to be 38. I stored this equation. So I'm going to come into my y equals. I see my equation there. I want my y value to be 38. So I'm going to zoom stat. And I'm going to find the point of intersection with my 38. So calc, intersect y1, y2, and that's pretty close. So 30, 38. So x equals 30 when y is 38. Therefore, 30 minutes is my answer.